This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. All right, this is example 3, working with the arc length of a circle, and we're going to do this problem. Find the radius of a circle in which the central angle pi over 6 intercepts an arc length of 200 meters and round to the nearest tenth of a meter. Right, so actually we are given the arc length for this problem and we are trying to find the radius. So again, remember, we started out with a radian measure of theta, which is S over R, and then we have this formula for the arc length, or S equals R theta. So we could use that formula to do this problem. Right, so we know that S equals R theta. Now, if you want, you could solve for R before you plug in your values. That's up to you, or you could leave it the way it is. I think I'm going to leave it the way it is, and here's the reason. Because when I divide both sides by theta, I'm going to have a complex fraction because I'll have this fraction, pi over 6, in the denominator. So I'm going to go ahead and leave it as it is. So what do we know? We know that the S is 200 meters. We're trying to find R, and theta is pi over 6. Now, it doesn't have degrees, which means it's in radians, and so we could use that for theta. So let's plug these in, and I'm going to leave off the meters for now. At the end, the radius will be in meters. So we have 200 is equal to R times theta. Now, I'm going to write that as pi over 6 times R instead of R times pi over 6. So times R. And the only reason is because I'm used to seeing the variable we want to solve for to the right with the coefficient on the left. Okay, I'm going to move this over a little bit. So now how do we solve for R? This is just like if it was 3/4 R. So we just can multiply by the reciprocal to both sides, 6 over pi on both sides. So that way the pi's cancel, the 6's cancel, and I end up over here with 1200 over pi. Now, 1200 over pi. And if the arc length was given in meters, this must be meters as well, right? So that's the radius. That's the exact answer, right? That's exact. But the question says to round to the nearest tenth of a meter. So then we go ahead and just plug that in our calculator. So we put 1200 divided by pi. Make sure you use the actual value of pi. And then rounding, just so you know what my calculator comes up with so that you can see how I round it. My calculator comes up with 381.97186, blah, blah, blah. So the question is, I want to round right here, but if that's a 9, it's going to, see, this is a 7, so this has got to round up. Okay, so it's going to add, this will end up being 382.0. Now I'm showing 0 so you can see I've really still gone to the nearest tenth of a meter. So rounded, the answer is 382 meters, or you might say 382.0. But be careful, don't put 381.0. Careful, you're rounding up. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.